Welcome, YouTubers. This is how to make some clear ice. And I guess before we make some clear ice, it's kind of difficult to make clear ice. You'd think it'd be pretty easy, but actually takes a little bit of work. But why would you make clear ice? Well, just not a real good reason to make clear ice. Other than it looks cool. On the left, you've got some in this picture here. You got some, ice box, ice dispenser, frozen quickly. It's all cloudy. And on the right, it's a little hard to see, but you got a spear in there that's got clear ice. So it just really looks aesthetically nice. That's probably the only reason to do it. It does technically melt a little bit slower because those cloudy ice is really a bunch of fissures and holes and stuff like that. And once water or whatever liquid you're using or air gets in there, it will make more surface area and it will melt quicker. So clear ice will last a little bit longer. But basically, it just looks cool, and there's no denying that. So that's why you would have clear ice. In order to do clear ice, I'm outlining a 4-step process. Step 1 is directional freezing. Step 2, partial freezing, tempering, shaping, and I'll talk a little bit about storage. You have to go through these processes to do this. This is why it's a pain in the butt. The enemies of clear ice is cloudy ice, or particulates in particular are what are in the water. Even if you boil it or filter it, you seem to still have some particulates left, and those can be minerals, those can be dust particles, it could be whatever gets into ice. And when it freezes, it will create those fractures. It wants to go into a solid form, and all the molecules want to line up nicely, and they're not doing so. Another enemy of clear ice could be bubbles. That doesn't happen very often, but clearly when you see bubbles in ice, that's little air pockets. That can happen a variety of reasons, but it's more often that you'll see the particulates. So let's go to the next slide. So step 1, you're going to have to do some directional freezing, and the concept here is in red, which is as water freezes slowly, it'll push particulates into the remaining liquid, at least until it's saturated. So that's the concept. It works, and what it leaves behind, as it freezes and it pushes the particulates into the remaining liquid, you'll get clear ice. Professional ice people, we'll talk a little bit about professional ice here. They'll have for directional freezing, they'll have a machine which you pour water into a holding tank. It'll freeze from the bottom, and at the top half of the tank, they'll put pumps that push the water around, and that'll keep the water moving and keep the particulates moving, and any bubbles will escape via gravity to the top. And so they'll do that for 3 days or something, and they'll get a nice 12-inch high block of ice, perfectly pristine down the bottom. And then they'll get a hoist to hoist it out. There'll be like a 300-pound block, and then they'll get some bandsaws and chop off the top portion of it. And then they'll continue to use bandsaws to cut it to whatever size squares you want. But all that requires a lot of equipment, machinery, and an ice-cold area, 18-degree type stuff to do the work, the bandsaws and stuff to do that. So we're not going to be professional ice makers here. We're going to be amateur ice makers, but we'll still use directional freezing. So you'll fill a small cooler with water and leave the top open, so the 5 sides of the cooler there will provide some insulation, which will make the top freeze. The top will be open to the air in your freezer, and that will create thicker, the top will freeze earlier. I don't really advocate boiling water. A lot of people do boiling water and say that that's that alone does it for them. Other times you just have mixed results, but it's just a lot of effort. You got to put a lot of energy into that and boil a bunch of water. It's messy. Distilled water doesn't really seem to work anyways. That still has particulates, so I just skip both of those and I just put tap water. For me, it's tap water. If you can't get tap water to work, I guess you could use some straining or something like that. But for me, it's tap water, and I place the cooler into the freezer with the top open, and again, the open cooler will make the ice at the top freeze first, and that's what you're doing for the directional freezing. There's a picture of my cooler. This time I decided to put an optional elevated tray. So I've got some 1x1 cubes, 1-inch cubes tray in there, and I've got it elevated on a piece of plastic with leaving some holes to the bottom. You got to put some holes in the tray so that the particulates drain out the bottom hole or get pushed out the bottom holes as the top freezes, and you just pour the water up to the level of the top of your ice tray. I didn't do a great job here, but you don't need the ice tray. You'll actually get a little bit more ice if you don't put the ice tray in there, because it'll just be a nice big, size of your cooler. You'll have a piece that you can chop up later, but the tray sort of assists a little bit in shaping of the ice. Makes nice little squares or cubes. So that's what I was going to attempt to do here. It's my first time with this tray. We'll see how the results came out. So the next step is partial freezing, and this is another key. You have directional freezing, and then you're going to have partial freezing. And in red there is the concept again. If frozen thoroughly, the fragile ice tends to spread cracks from the particulates, particularly if you let it, if it goes all the way in to the end, you're definitely going to have some particulates. There's no more liquid left, and it's going to get that cracked fissures, or whatever you want to call air gaps, cracks, fissures, whatever you want to call them. I don't know the technical term. And those will spread out randomly. Sometimes they spread out to much of the cube and waste it, and you get cloudy cube all the way through. Other times it's just weird tentacles shift out. So it's kind of random. But depending on the quality of the ice and the way it was done, it may ruin your ice batch if you let it freeze all the way. But the key is if you leave some liquid portion, then hopefully if it hasn't been, you'll have reduced the cloudiness tremendously. So again, we're going to leave the cooler in the freezer for 24 hours. That's a good starting point for a freezer of that size that we're looking at. And so that the top builds a nice layer of clear ice and the bottom retains a liquid core. And you'll need to experiment on your time by your setup and what you're trying to do. And usually the deeper the cooler, the better, because if you have a really shallow cooler, that doesn't leave you a lot of leeway in the freeze time that your liquid, the more liquid you have underneath it. I know that's not going to freeze, and you're going to spend a lot of energy cooling it down and all this stuff like that, but this is why it's a pain in the butt to make clear ice. So we're going to do that. We'll go for 24 hours here. And so after 24 hours, this is what my cooler looked like coming out of the freezer. Had something really funky happen here. I think the molds weren't holding the ice in, not enough friction. It was brand new mold, so kept on growing ice and pushing ice. I got like twin towers sitting out there, a 1-inch block, and you can see some bubbles down underneath. So that probably wreaked havoc. I'll have to experiment a little bit more. If you look really close, you see I kind of had it at an angle, not flat. So the left hand portion here is covered with ice, right, and the right hand is underneath a little lower. So I had all kinds of funky things happen, but in general it worked, and it worked just fine. You can see how clear the ice is, sort of near the top of the tower there, and you can see just by looking at some of the ice in the middle, it's kind of good looking. So it worked, and obviously if you don't have this silicone tray in there, you'll just get a nice thick layer of ice at the top of the cooler. So another important step is step 3, and you're going to do some tempering here, just like you would with any solid, whether it be aluminum or what else. How you temper it makes a difference. So the concept here in red is that extremely cold or new ice is fragile, and ice that is sat out for a while or tempered seems to get more aligned, is less likely to fracture when cut. So you don't want to cut your ice right away. You can even ruin the ice and create cloudiness and cracks all the way down it. Whereas if you let it sit out a little bit, get a little bit of a water gloss around it, I know it's melting on you, right? But you have plenty of ice. You're going to just throw away that melted part, and it'll cut better for you is what I'm trying to say. So I usually remove the cooler, and depending on what the ice cube size were, and you can let it sit for half an hour, maybe 15 minutes is good enough. It'll come out of the cooler. The sides will melt it enough, and it will flop out, and then you just let it sit for another 15 minutes or half an hour total. And then you probably go to work on it, right? Depending, as long as it's not melting too badly on you and ruining your shapes and stuff like that. You'll want to drain the liquid portion at this particular point in time, and sometimes it'll be encapsulated. I'll show the picture next. And if you're using a tray, chip away at the outer ice. That's a good technique. But you will get some fractures as you chip away the outer ice, so you can let it all sit and then do it after it's tempered. Maybe you get recapture a little bit of that outside ice. Otherwise, you don't need it, you don't need it. So here I got a picture. This is the exact same cooler. You can see how crooked it is in the left-hand picture. As terms of straightness I didn't do a great job. But on the left-hand picture in the lower left, I drew in the word water, and you can see that bubble in there. So the ends and the bottom froze to some small thickness, like a half an inch. The corners are really thick. But up top, you've got at least an inch and a little more than an inch on one side, on the left side, of pretty clear ice. Unfortunately, it didn't freeze. Some of the chambers of that tray did not freeze on the bottom, and the twin towers were pushed out of the top of it, so a couple holes. So that's kind of weird. But you can see it is really encapsulated in ice. And if you look on the right-hand side of that picture, you'll see that that whole pocket in there was water. And matter of fact, you can, where the twin towers were on the right-hand side, you can see it peeing out putting water out of the ice tray there. So it was draining somewhat, but eventually you have to break one of those sides of relatively thin ice and get the water out of there. That's a good deal to do before you work on it. So you drain the water and let it temper, right? So step 4 is shaping. Theoretically, it'd be like glass, like a plate of glass, or some of the other stuff like ceramic tile. If it was thin enough, you'd score the surface and then press on that score, and it would split it. But ice is usually a lot thicker, so you won't get great results necessarily. But you do want to score it so that it would do that. I've resorted to not scoring it in some cases. I'll just take what I'll do is. You can wear gloves if you want to, especially if you're going to handle ice a lot. Not that, it's a safety hazard, just ice gets cold. And if you're sensitive to that. Otherwise, I just use a bread knife, lay it on top. And I use a bread knife not so much for the serrations, for scoring. It's just a long, flat knife as opposed to a chisel or something, right? And a long, flat knife that'll lay all the way across the ice, and then I just tap it with a hammer, and usually it'll not be exactly straight. It'll be straight at the top, but it will angle off, right, or something. And sometimes it comes out really good. So you just have to practice a little bit at that. Realize that the thicker it is, the more likely it is to sort of walk as it breaks through the ice. But you'll crack off pieces and keep doing that repeatedly. Score it if it helps. But I just use a bread knife with a little hammer and line it up, tap it, boom. It breaks pretty quickly, pretty easily. And you don't have to hit it particularly hard. And you just chunk it down to the sizes you want, and they look relatively square. They look good, and they're clear. Other cutting items I've seen used, like an ice pick or a chisel, they work easily well, especially if you want to chisel the corners and make it into a diamond or something funky. You can look up some other YouTube videos on that. I'm not going to do that. That's not my forte. But here, we've got some of the tray ice that popped out, and if you look at a couple of the cubes, like there's one in the upper left, and there's a couple in the lower left bottom, and a couple in the upper right where I had some problems because of the tray not getting fully enveloped, or the ice was overhanging on 3 of them on the tray and the other 2. So those have some goofy looking surfaces where I had to either knock the ice off or they weren't perfectly formed at the bottom all the way to the hole. But overall, the rest of the pieces ice is like the 4 across the middle and the 2 up top and the 1 down bottom are really, really nice clear cubes. So it does work. Not a lot of effort. You just got to wait around. I probably needed to let it sit for a little more than 24 hours with the setup I've got. I'll try that again. Try to get a perfect batch of ice and not overflow the mold would be a good thing, because then you don't have to do any cutting, right? And they come out really nice and square. Or if they're short on one dimension, so be it. But they're nice cube-looking ice, clear. It's looking real good. So it works. Storage-wise, my tip here is just place your cubes into a Ziploc and put them back in the freezer. They'll be fine as long as you don't jostle them around. Go back in a little while. Probably a half an hour is too much. I'd probably do a little bit less. You just want to break them apart because there is water on the outside of them due to the melting process that you've had. You saw the water hanging around on the cutting board I was doing, and they'll try to freeze together. So you try to want to keep them from freezing together. Otherwise, you'll just have 2 cubes stuck together in a weird manner. Won't look great. Or you can throw them away. I mean, they will frost over in the Ziploc bags. And once you got that, you're in pretty good shape. Even though they look like they're frosty, but as soon as they melt a little or you put some water over it, they'll be crystal clear again. It doesn't affect the structure after that. So you want to go back in and just jostle the bag a few times and make sure you got a nice cloudy and they're all separated. Then they're good to go. Just leave them in the freezer. and take them out when you need them. The other tip is not to pour slowly over the ices. Otherwise, if you ever put, warm soda or something or whatever, warm alcohol over an ice, they'll tend to crack. So you want to pour them gently just to make sure you don't crack them at the end if you want really good presentation. So that's it, man. That's my concept on ice. You can see I've got 2 cloudy ice cubes. I used another silicone tray exactly the same without the holes in the bottom and just melted them fully through. And you can see I've got all that cloudiness. That's not what you don't want to do, but I do on number 1 and number 2. I've almost put a highlight with an arrow. You can see that I've got some square cubes there that I took back out of the Ziploc bag, and they're in good shape. 3 and 4 are just random parts that I chunked off. If you look, they're a little bit irregular, but still pretty cool looking. So that's what you're trying to accomplish. That's all we're trying to do here, and it was a real pain in the butt to get the clear ice, but the end result is, hey, it's pretty cool looking, right? And even though it's not as efficient as just cooling it all the way, it requires some processing and some handling. A lot of times it's well worth the effort. All right, so this is how you do it. All right, thank you.